Okay, let's check out this first problem. We want to get the velocity time from this position time graph. So this first slope right here is a zero constant slope. So I'm going to look for a zero constant velocity. So it looks like B and C are good options. Then I'm going to look at the next part of the slope. It's got a negative constant slope. Only C has a negative constant slope for that part. So I'm going to go with C. And it turns out that I got it right. Yay. I'm playing by myself. Okay, so this next question, let's check this question. The slope at a point on a position time graph of the object gives me, okay, so A and B are both possible, but B is more accurate because it's actually the velocity. Speed would be okay if it was the only version there, because remember, only, anyway, it's velocity because it gives us the direction. Okay, the slope gives us direction, so velocity works there. So I'm going to go with B. What's that? Is that right? Did I do that right? Oh, okay. I don't know. Let's see. Okay, so I don't know. Anyway, um, okay. Oh yeah, I just didn't hit it in time. Okay, so I got it right. Yay. Okay. Now the it says which of the following position graphs matches a velocity graph. All right, so we need a slope um, that is constant and positive. So that's constant. So B is constant and positive, and so is D. Okay, then we're going to have no velocity whatsoever. So B and D mathematically would work, but B is saying that setup. So if we look at B, oops, I didn't enter an answer in. If we look at B, what that's saying is you all of a sudden appear back here at the reference point, back here at zero. D is a better answer because you end up at that, you stay at that particular position. All right, so going with the constant velocity, then you stop at a particular position. So this one makes more sense. This one, B is mathematically okay, but D is the right answer as far as physics is concerned. Okay, so then let's go to our next thing. Question number 4. Okay, which velocity versus time graph goes with this position graph? So again, we're going to go with the slope here. So we need a constant positive slope and then eventually getting a zero. I'm sorry, that's constant positive slope. So we need a constant positive velocity. So C is the only one, okay, because it's got a constant positive velocity and then it goes down to zero. So here we hit C. Just oops. Never mind. Let's just go over to. Okay, I'll just go through all of these without entering in the answer. Question number 5. What is here's a position graph at t equals 1.5 seconds. What's the velocity? So remember, on a position time graph, the slope is the velocity. So this slope between 1 and 2 seconds is the rise, which is 20, divided by the run, which is 1. So 20 divided by 1 should be B. Yay. Okay. All right. Then next question, question 6. Okay, when do objects 1 and 2 have the same velocity? Okay, so number 2 has a velocity that's equal to its slope right there. Number 1 has the same velocity somewhere around here, because if I took a tangent line or if I drew a line right there, like somewhere around there, it would have a slope that's approximately equal to this slope right there. So sometime before t is equal to 0. All right, so A is the correct answer there. And then next, question 7. Okay, here's a velocity time graph. What's the object's position at 4 seconds? So remember, on our mnemonic, XVA mnemonic, going from velocity to position, I've got to take the area. So this area here, so I have two objects here. I have this square, if you will. 4 times 2 is 8. Then this triangle, 4 times 2 divided by 2 is 4. So 8 plus 4, let's look at that image again. If this is 8, this area is 8, and this area is 4, I add the two together to get 12. Okay. And then question 8. So this object is slowing down to the left. That means acceleration is to the right. So we call to the right positive. So acceleration, the correct answer there is A, because acceleration is positive to the right. So that's actually possible. Okay. And then question 9. Okay, so now this person is slowing down on the way down when they went after Mike jumps on that. So that means his velocity is decreasing on the way down. So his acceleration should be pointing upward. Okay, so the correct answer is A there. That's a tough one. Okay. All right, so question number 10. Okay, the cart speeds up while moving away from the origin. What do velocity and acceleration graphs look like? So speeding up, moving away from the origin, we're going to assume it's a constant velocity. Okay, so constant, it speeds up. So the velocity is not constant. So let's assume it starts with a velocity of 0 and increasing its velocity like that. If I take the slope of that graph, it would be positive and constant. So the answer should be B. Okay, next question. 11. So now it's slowing down. All right, so I've got velocity. It's already moving. Okay, so let's check out C here. It's already moving and its velocity decreases, so I need a negative slope. That'll give me a negative acceleration. So the answer there should be C. Okay, and then finally, number 12. Check out this question. A ball is tossed straight up in the air. At its very highest point, the ball's instantaneous acceleration is negative. All right, it always points downwards, even when it comes to the top. Okay, so answer there is B. All right.